Hello everybody and welcome to today's lesson in the wonderful world of mathematics. My name is Pranav Madabhushi, as you can see on the board here. You can call me Pranav Madabhushi, P-Dog, P-Swizzle, whatever you want. Now I know you probably, now we're going to talk about triangles today, and I know you probably know what it is, but a triangle is a shape with three sides called edges and 3 points called vertices. And the cool things about triangles is the angles always add up to 180 degrees. Yes, Pratiti?
How do you add up to 180 degrees, P-Swizzle?
That's in the definition of a triangle, so at least the triangles you'll be working with. And now I want to tell you about the different types of triangles. There are 3 triangles based on the side, or the lengths of the sides, and 3 triangles based on the size of the angles. So the first one is called an equilateral triangle. Make sure you're writing this down. Notes. And equal, the suffix means, or equal, the prefix means equal, and the suffix means side. So can anyone tell me what an equilateral triangle has?
Equal sides?
That's very good, Connor. So the side lengths of an equilateral triangle are equal, as well as the angle lengths. And the angle lengths are all, angle sizes are all 60 degrees. 60 degrees. Now we have an isosceles triangle. And like an equilateral triangle, an isosceles triangle shares equal sides and angles, but only for 2 sides. Yes, Pratiti?
Wait, why do you know that they're 60 degrees? Why aren't they like 50 degrees?
Well, can you tell me what 60 plus 60 plus 60 is?
No.
Can you tell me what 6 plus 6 plus 6 is?
No.
Can someone tell me what 6 plus 6 plus 6? Connor?
18!
18 is correct. So now if you add zeros to that...
Why would you add zeros to that?
Well, since this is 60, this is a way to simplify it. We get 180, and what did I tell you about 180 degrees?
You didn't explain why you know it's 100.
It's in the definition of a triangle. A triangle, 3 angles, and those angles add up to 180 degrees. Okay, so next we have a scaling triangle, and in the triangle world, no one really wants to work with these kinds of triangles because none of the angles and none of the sides are equal. Yes?
Will you ever work with triangles outside of this classroom?
Yeah, for many different occupations such as architecture, construction, design, and whatnot. Also, any form of mathematics, you're probably going to use triangles. Now let's move on to triangles based on angles. So we have an acute triangle. And the cool part about an acute triangle, or what I think is funny because I have an awful sense of humor, is that the smallest triangle is called a cute one. Now, yes?
How is it the smallest?
Well, you'll see in a second, this has an angle degree measure of less than 90 degrees. So each one of these angles has to be less than 90 degrees. Otherwise, it's not acute. Next, we have a right triangle, and we show this as 90 degrees, and we show it symbolized by this box. This one you'll be working with a lot in future years, especially trigonometry, geometry, all kinds of things.
I'm not taking trig.
Please keep it down, Leonard. What's this side called? Does anyone know?
Pythagorean.
That's not it.
Hypotenuse.
Hypotenuse, yes. And a hypotenuse is always the longest side of a triangle.
They're bullying me.
Please stop it, Connor and Leonard. And the cool thing about a right triangle is a guy named Pythagoras, who his theorem is named after, although he didn't really discover it, or it's not known if he was the one who came up with it. We have a theorem that says a squared plus b squared equals c squared. And if a is this side length, b is this side length, and c is this side length, then a squared plus b squared equals c squared. Okay? Lastly, we have an obtuse triangle, which the angle length is greater than 90 degrees. And this is obtuse. And so, Mr. Behrens pointed this out at or Leonard pointed this out at our last class, that sometimes classifications of triangles may overlap. So Leonard, can you tell me what an acute triangle might also be from this list of 3?
An equilateral triangle.
That's good. So if this were to have 60 degrees on all spots, it would be equilateral.
But it doesn't have to have 60 degrees.
It doesn't have to. It just has to be what?
Less than 90.
Less than 90. And similarly with this, if this were to have 45 and 45, which would add up to 180 degrees, this would be also an isosceles triangle. So now I want to tell you about a little chant to help you guys remember this, and I'll be distributing this after class. If everything's going right, you have an angle of 90. But if things are a little cramped, you're acute. Be careful not to go overboard. Use your triangles wisely, because if you stretch too far, you're obtuse.